Okay, I'm going to try taping this way today, at least so you have a wider screen on your computer. Today we're looking at the cosine law. Okay. First of all, let's review when to use primary trig ratios, which would be SOHCAHTOA, when to use sine law, and then when would we use the cosine law. Just give me 1 second here. Okay. So primary trig ratios is whenever you have a right angle triangle, okay? Right angle triangle. When you have a right angle triangle, use primary trig ratios. That's your sine, cos, and tan ratios. Use your sine law when you don't have a right angle triangle, but you have a complete ratio or the ability to get a complete ratio. So you have an angle with corresponding side that are both known. Okay? In other cases, after those, if you've exhausted those possibilities, now we're into cosine law. Okay, so the cosine law you can use in two different cases. First case is what I call is when you have an angle sandwich. You are given a side, you are given an angle and another side, and the angle is contained in the two sides. In this case, you could solve for this side and this side alone. After you have that side, you can use the sine law to solve for whatever you want. The second case you can use the cosine law for is when you don't have any angles, but you have all three sides. Okay, when you have all three sides, you can solve for whatever angle you want. Okay, be careful though, when we get into this, I'll show this. It depends on how you put your formula in. Okay, so let's get into example one. Example one, I just have this triangle I quickly drew. We have a, first of all, let's try to exhaust our resources here. We cannot use primary trig ratios because we do not have a right angle triangle. We cannot use sine law because we do not have a complete ratio. That is not a complete ratio because that is an unknown. Okay, so I don't have that angle there, I don't have that angle there, and I don't have that side. And I don't have the ability to get those angles by subtracting 180. So on this case, we have to use the cosine law. The cosine law, remember, is if I want to find x, let's call this x, we'll call this one y, we'll call this one z. So x squared is equal to y squared plus z squared minus 2 times y times z times the cos of angle x. That is angle x over there. Angle y, angle z. Okay? So the most important thing here is if you are finding x, you are using the angle of the corresponding side to x. Okay? If you were trying to solve for y, you would need that right there. Okay, so knowing this, we now have x squared is equal to 17 squared plus 15 squared. It does not matter the order you write those in. If you wrote it 15 squared plus 17 squared, that's fine. Minus 2 times 17, same here. The order doesn't matter. 15 cos of 43 degrees. So you can go through and separately calculate 17 squared, separately calculate 15 squared, do negative 2 times all of that times that. I'm going to do this all in one calculation. I'm going to do actually two calculations. I'm first going to find what x squared is and then square root it. So I have here 17 squared plus 15 squared minus 2 bracket 17 bracket bracket 15 bracket times cos 43, and I get 141. Okay, that is x squared. It wouldn't really make sense that if I had a triangle of 15 and 17, now that side is 141, and it only opens up to a 43-degree angle. Okay, so recognize that a lot of people will make a mistake and stop here. We still need to find x, so we need to square root both sides. So therefore, x is equal to 11.9. Okay? So that makes a little more sense in a triangle of 15, 17 with a 43-degree angle. That is 11.9. So that's cosine law when finding a side. Now, cosine law when finding an angle. Well, first of all, if I'm going to go to the general cosine law, and I'm going to look at it like this. A squared equals B squared plus C squared minus 2BC cos of A. Again, most important part about the cosine law is if I'm finding side A, I have angle A. Well, now I'm going to look at the case where I want to find a side. For example, let's say I have sides A, B, C, and I have side A, I have side B, and I have side C, and I want to find my unknown is angle A. Okay? So we're going to rearrange this algebraically, and then you can use that from there. So my first step is to, well, get rid of what I can. Again, I'm trying to solve for all of cos A here. So I want to bring what's furthest away over first. So I'm going to subtract B squared, subtract C squared from both sides. I'm left with A squared minus B squared minus C squared equals negative 2BC cos A. This is all multiplied, so I'm going to divide both sides by negative 2BC, negative 2BC. That is going to cross out here, and I'm going to be left with, on this side, cos A is equal to A squared minus B squared minus C squared, all divided by negative 2BC. If you want to go ahead and bring cosine over and do the cos inverse right away, that's fine. I'm going to recommend that you guys leave it here and then take the cos inverse once you have a 4 decimal place to answer. Okay? So this is what we have. Writing it out again the way you normally write it. Cos A is equal to A squared minus B squared minus C squared, all divided by negative 2BC. Most important part, if I am finding the angle A, I am starting with side A and subtracting the other two sides from that. Okay? So let's go to my second example here. Well, let's say I have this triangle. I have 94.5, 94.5, and a 15.3 at the bottom, and I want to find what angle that is. So going to my formula I just did, that cos A is equal to A squared minus B squared minus C squared, all divided by negative 2BC. So let's fill in what we have. In this case, we know that A is going to be theta. Cos theta is equal to an A squared, this is the most important part, has to be 15.3. It has to be the one across from the angle that you're trying to solve for. So 15.3 squared, now the other two doesn't matter, even though these two are the same, minus 94.5 squared minus 94.5 squared, all divided by negative 2 bracket 94.5 bracket 94.5. Cos theta is then equal to, again, very important, put your numerator in brackets, put your denominator in brackets when you put in your calculator. Open up a bracket, 15.3 squared minus 94.5 squared minus 94.5 squared, end my bracket, divided by, open up a new bracket, negative 2 times 94.5 times 94.5. Yes, you can use brackets there instead. End that bracket, and I get cos theta is equal to 0.98 0.969. Please keep 4 decimals rounded correctly to the 4th decimal there. And finally, to solve for theta, theta is equal to the cos inverse of 0.9869. Theta is equal to cos inverse 0.9869, an angle of 9.3 degrees. Okay?